In this video, we're going to talk about collections in .NET. And if you're enjoying the content on this channel, please be sure to leave a like and subscribe. It'll really help the channel out. So what is a collection? Obviously, a collection is different from a single object. Now, if you've watched my video on .NET types, you will have seen how you can create objects that have specific fields. But what if we just want a collection of a lot of objects that have the same structure? So that's where collections come into play. So generally speaking, a collection has multiple items. Sometimes it's resizable, and sometimes it's not. So another difference with collections is that sometimes they might be based on order, like an array has things that are in order, or they might be based on keys, like looking up by first name or last name, or any other structure that you make into a key. Importantly, some collections may have no particular order, so things may always come out in the same way, but intrinsically they actually have no order. So for example, a set has no order, whereas a list has an order. One of the fundamental collection types in .NET is actually an array. So an array is an entire single chunk of memory with all of the items in that piece of memory. Other collection types may not actually use a single chunk of memory. So they might have items that form the data structure that actually exist in different places on the heap. Another hallmark of collections is that you can iterate over them, and by that I mean you can go from the first item all the way to the last item using some kind of a looping structure. And also importantly in .NET, we've got two different types of collections. So we've got generic collections and non-generic collections. So we'll talk about that next. So in the history of .NET, the first version did not come with support for generics. And what this means is that a lot of the collections were based on objects. Now that's fine if you don't mind casting, but there are now better ways to handle your collections. The collection types that were initially available fell into a small number of types. So we have an array list, which is a lot like an array, but it's also a list. And internally it actually has an array that backs the data structure. We have hash tables, we've got stacks, and we've got queues. So for every type of collection, we also have an interface type for it. For the initial version of .NET, these interface types were also not generic. So the main ones are enumerable and enumerator, and we'll cover those in a minute. iCollection, iList, and iDictionary. So the most fundamental interface type is enumerable, and that works closely with enumerator. So what enumerable allows you to do is retrieve an enumerator. That's all it does. Enumerator, on the other hand, allows you to move throughout a collection. It's got three main components on it. It's got the ability to move next, the ability to look at the current item, and the ability to reset your position in the enumeration. So when you start enumerating a collection, you are actually placed immediately before the first item in that collection. So you must always call move next first. If the collection is empty, then move next will return false. If it's not empty or you're not yet at the end of the collection, then it will return true. Then you can read the current item. If you want to reset the position in the collection, you call reset. However, this is not supported by all collection types, and personally I'd recommend avoiding it. The next type of interface is iCollection. So this allows you to do a bit more than enumerable. It allows you to see how many items are in a collection, add and remove items, ask whether the collection contains an item, basically everything other than being able to get specific positioning of items in a collection. If you want that, then you need to go into the next specialized interface type, which is iList. So iList allows you to get that really precise add remove capability or get and set from an index on your list. So the last type is iDictionary, and this allows you to key items by a given key. It doesn't have any particular order, and the keys are objects, as are the values inside of it. So I'd recommend not using the non-generic interfaces primarily, although you'll find when you're implementing your own collection types, you will need to implement these interfaces as well as the generic ones. So let's talk about generic collections. So generic collections are much safer and they're much better. So they're safer because you're always dealing with a particular type of item rather than objects. So you shouldn't need to cast. They're also better because when you're using value types and collections, if they're being cast to objects, then they need to be boxed. And in reverse, when you retrieve an item from the collection, they need to be unboxed. So the boxing and unboxing operations, they actually take time. So your collections will slow down your program if they're non-generic. So it's better to use the generic versions. The main types of generic collections that you'll find in .NET are very similar to the non-generic ones. Basically, you've got your dictionaries for key and value pairs. If you just need keys, then you use a hash set. And linked lists allow you to have arbitrarily large collections that don't have any initial capacity. So unlike lists, which when they reach their capacity, they can continue to grow, but they need to make a copy themselves. And this can slow down your program if you need to make that copy. And of course, queues and stacks. So we also have generic interfaces. Just like we have IEnumerable and IEnumerator, we have IEnumerable of T and IEnumerator of T. These do exactly the same thing as their non-generic counterparts, except they have a type parameter. We also have iCollection of T. Again, does exactly the same thing, but it's generically typed. Also iList, again, same thing as the non-generic iList, and iDictionary, which is also the same as the non-generic iDictionary. So as I've already said, most of these interfaces inherit from their non-generic counterparts. One important thing is that they're also read-only interfaces. Now, read-only is just a interface type. It doesn't actually change the underlying type. So if you cast a mutable collection type to its read-only interface, then it's still the same object. What that means is anyone who casts that back to the mutable structure can then change it, which means that the consumer of that object, which is relying on it being read-only, will have a bit of a surprise when the underlying contents change. So to avoid that problem, you can actually use a immutable collection. So immutable is always safe. You can rely on it not accepting any changes because it doesn't support modification. And therefore it will be thread safe and you don't need to use any locking strategies. One consideration though is that an immutable collection may be slower. And the reasons for that is that unlike mutable collections where you can add and insert items, if you wanted to do the same thing with an immutable collection, you actually need to make a copy of some or all of that collection, depending on the implementation of the data structure. So, if you're using a collection, how do you actually enumerate over the contents? So the primary way is using the for each construct. What for each allows you to do is enumerate the contents without too much additional work. It's based around an IEnumerable, which allows you to enumerate a collection based on move next and current of the IEnumerator. However, using IEnumerable is actually not a requirement to use for each. So anything that matches the pattern of IEnumerable and IEnumerator will actually work. So in other words, you can define a class that has a method called getEnumerator that what it returns also contains methods for move next, current, and reset. As noted earlier, the reset method may not always be supported, so I'd recommend not using that unless you're willing to catch exceptions. There's another important class that's used in collections called enumerable. This came along with the link feature, which stands for Language Integrated Query. This class contains a number of extension methods that do all sorts of things from aggregation to selecting, or in other words, changing the contents or creating other collection types. Importantly, most of the extension methods are lazy, and what that means is that they don't compute the results straight away. So if you applied a series of selects on a collection using the enumerable extension methods, they won't actually evaluate until you either copy the collection into another collection type, or you enumerate it, or in some way trigger the enumerator to enumerate. A couple of the useful extensions in enumerable are the ability to cast and filter based on type. So you normally do this when you're presented with an IEnumerable, so non-generic collection type, and you need to turn that into a generic version of that IEnumerable. So you call cast, and that will change every item into the type specified. If not everything is of that type, then you can use the of type method, which filters it down to that type. So using that method, you won't get any errors if it's not of the right type. Downside though is that if you're assuming that it's all of that type, then you'll get fewer items. So just be careful as to which one is needed. Alright, so that's the basic introduction to collections. So I'll have a quick recap as to what we've talked about. So collections can be based on keys or structured. They fall into non-generic and generic categories. There are many different collection interfaces, which are both non-generic and generic. Collections are usually enumerated. It's usually enumerated with the for each construct, but you can also use another loop construct for some collection types. And a key type is the enumerable class, which has a lot of extension methods used in LINQ. So if you found this interesting, please leave a like and subscribe, and thanks for watching.